our purpose is to provide education and advice to citizens and to City Council with respect to environmental sustainability issues. So here, this Learning Academy that we're starting, the goal this year is to actually have 3 or 4 of these in order to be able to continue the mission of education to the community. And you can see here on your screen, we've got just some general information about ESB for those of you who weren't really familiar with the board in the past. We're all citizen volunteers that serve on the board. Here presenting today is going to be Raj Pandya. He's the chair of the board this year. And then you can see also the names of the other members of the advisory board listed here. I'm a new member of the board. This is my first year on the ESB. And our city council liaison who attends the board meetings is Catherine Lewis. And we also have Public Works attend our regular meetings to give insight in happenings in the department. So let me introduce you to Raj so that we can get the show on the road. Raj is, like I said, chair of the ESB. He also is president of Shine Partners, which is a company that develops, finances, and operates solar energy and clean tech projects for commercial and industrial customers. He and his wife have lived in Bellaire for 13 years, and they have 2 daughters that went to Bellaire High School. They both are well beyond high school and both live and work in the Austin area. Now, he's going to talk to you all about residential solar and happenings in solar energy. During the course of this presentation today, all of the attendees are muted, but we do have the chat box, the question and answer open. And so what we'd like to do is have you asking questions in the chat. My job is just to be a moderator. I'm going to be reading that. If there's anything in there that we need him to clarify, I will try to interrupt and ask him the clarification question so that we can make sure everyone's understanding what we're talking about as he goes through. But in general, unless it is a clarification question, I'll hold them until the end and can ask the questions. Sometimes there will be the same question asked repeatedly. So are there any questions now that anyone wants to put in the chat before I start this? Okay, well, with no further ado then, I'll turn this over to Raj.
Okay, excellent. Excellent. Well, thank you so much, Allison, for the introduction, and thanks to all of you who are able to join us tonight. So we're going to start off with a little quiz here to kind of get us warmed up. I've got a famous quote that I'm going to read to you all, and in the chat box, I'm going to give you all a few seconds. I want you all to try to guess who said this, who said this quote. So the quote is, instead of chopping down the fence around our own house for fuel, we should be using nature's inexhaustible sources of energy, the sun, the wind, and the tide. I put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that. So give you guys like 5 or 10 seconds to kind of who said that, and again, put your answers in the chat box. We're starting to get some answers, but they haven't quite got the right answer yet. Okay, I'll give you all a few more seconds. Can we give some hints? It's an old quote. It's an old quote. It's an old quote. I'll go ahead and share it now. So it was Thomas Edison in 1910. Oh. So America's greatest inventor. He said that, well over 100 years ago. So Allison, did anyone come close on that? Yes, Eric Welsh got the answer correct. He did, just under the wire, right before you said it. Good job. All right, excellent, great. Well, thank you. Okay, so what is solar photovoltaic energy? So the word photovoltaic means light energy in Greek, and it basically refers to a technology that converts energy from the sun into usable electricity for residential homes, commercial buildings, industrial facilities, and utility scale power plants. Now, one thing I wanted to note right now is that this presentation today is not going to cover the technology of solar thermal technology, which is the technology that converts sunlight into heat in the form of hot water or thermal energy. So here's kind of a historic timeline of sort of photovoltaic energy going way back 300 BC. The Romans and the Greeks used magnifying glasses and burning mirrors to make fire and light torches. And then fast forwarding far ahead to 1839, the French physicist Edmond Becquerel demonstrated the photovoltaic effect, which is the operating principle for the solar cell. Then in 1883, the American inventor Charles Frick developed the world's photovoltaic cell and rooftop solar array using selenium coating on the panels to produce a weak electric current. And then in 1905, you can see a picture of a young Albert Einstein there. He published a paper on the photoelectric effect, for which he won a Nobel Prize in 1901, along with his very famous paper on the theory of relativity. Then fast forwarding to 1958, NASA pioneered early PV technology, including launching Vanguard 1 as the first spacecraft to utilize solar panels. And you can see it's pretty tiny, but there's a few solar panels all around it there. And then as of last year, 2020, the US solar industry employs 250,000 people, has deployed over 2 million solar PV systems, totaling more than 90 gigawatts of solar capacity, which is enough to power 16.5 million homes. So this is a map of the solar photovoltaic potential in the USA. You can see from the legend at the bottom, the areas that are a little bit more red in color. Those are the areas that have the highest PV potential, which you would expect. That's the desert Southwest. But if you look at the legend on the bottom, Houston is kind of in the middle, a little bit above average, sort of in where the gold color area is. And what this basically is telling you is that for a solar panel that would be in the Houston area, it would produce 4 kilowatt hours per kilowatt per day, or 1461 kilowatt hours per kilowatt per year. So again, we're going to get into the numbers later, but just a quick math there would be if you have a 10 kilowatt system in Houston, you should be able to get around, for a new system, around 14,610 kilowatt hours in that year. But what this is also showing you is for that same exact solar array or solar panel, if you go to other parts of the country, you can get anywhere from 25 to 40% more electricity out of that solar panel, just because the solar potential is so much better.
Bryce, if you could just maybe put the kilowatt hours in context for the attendees. So like a typical home uses how many kilowatt hours per month?
Sure, yeah, and I'm gonna really get into all those kind of details later. But yeah, kilowatt hours. Roughly, I would say for a 4,000 square foot home, I would say on average about 25,000 kilowatt hours per year. So that's about average of what a person would consume. Typically just looking at say 2,000 kilowatt hours per month. You can kind of get that when you look at your electric bill, and you can see that from other sources as well. So so one of the things in general then about solar is the predictability and the certainty is really high, just because we've got all of these data points all over the country and all over the world through devices called Pyranometers. I've got a little picture of one down here, and they're just basic devices that measure sunlight data. So we have just very robust data sets all over the country. In Houston, we have one at Hobby Airport that's been there for like 50 years. And we've got all of this, sunlight data from the past. And so the ability to project in the future, it's pretty accurate. I would say, plus or minus 5%. Some years, not as much sun, some years more, and other years more. But that's one of the sort of the attractive aspects of solar energy, is that there's a pretty high level of predictability of the electricity that the systems will generate.
Oh, Raj, before you start on the next one, I just want to, so we have had quite a few people join since we initially started. Okay. And just to let everyone know that's joined, if you're just getting familiar with what's going on here, if you have questions during the presentation, please use the chat, the question and answer function. My job is just to moderate, and I'm collecting those questions. When it's a clarification, I'll go ahead and interrupt Raj and ask him to clarify. But otherwise, we'll hold those to the end because we do have a series of questions that we'll go through. So just to let everyone know how we're operating this. Okay, thanks, Raj.
Okay, great. Thank you, Allison. Okay, so why do homeowners typically install solar? It's usually a combination of these 4 reasons: to save money, to have energy independence, or to have the latest technology. I would say a lot of folks who have solar, possibly on the call or who are considering it, would probably fall into one of these categories or a combination of these categories. And even folks that are not residential customers, even sort of commercial and industrial scale customers, it generally falls into these, kind of, let's say, reasons or rationale. So how does it work? This is a very simple diagram. Essentially, the sunlight hits the solar panels and converts it to DC electricity, and the DC electricity flows to the inverter, here shown as number 2, and then the inverter converts the DC electricity to AC electricity, and then that goes to the electrical panel in your house, and then that flows to provide all of the power for your home. Depending on the size of the system, you'll most likely have to supplement that solar electricity with power from the grid. So you typically have 2 sources of, during the daytime, you'll have 2 sources of electricity come into your home. One from the solar energy system, and then the other from the grid. And then, of course, when the sun sets and the solar energy system is not running anymore, then all of the electricity would come from the grid. And so what's also part of this is a special utility meter that has sort of a bi-directional capability. So your normal utility meter without solar, it basically tracks the electricity coming in one direction, coming from the grid to your home. But when you have solar, you have to track it both ways, because there are going to be some instances where the solar energy system will overproduce and it'll send electricity back to the grid. So you have to have a utility meter that has the ability to track that properly. Shown here also, and we'll talk about this a little later, is optionally a battery system, or a battery, if you will. And batteries nowadays are really excellent sort of fits with solar energy system, and they mainly perform 2, kind of a couple of key functions. Something we call load shifting, which is sort of moving electricity around in a really smart way for various value creating purposes. And then, of course, for emergency backup purposes. And then, as is mentioned at the bottom here, the expected life of a solar energy system is 25 to 35 years. Some folks say 40 years, but in general, that's what the expected life is. So what are the optimal?
Raj, yeah. Real quick before you leave that one, we've had a few questions about the diagram that you showed about whether you can receive solar energy if the grid is not functioning. So, like, if there's an outage, if you have solar on your home, can you still receive solar power?
Right. And I've got that as an FAQ in the end. So the quick answer is unfortunately no. There is a sort of a safety feature that is set up currently with solar. If you don't have a battery, basically tied to the solar energy system, the inverter automatically shuts down as well. And the reason for that is because you can imagine if a lineman, somebody's working doing repairs on the electrical line, then if you have a source of energy that's feeding back into the grid, then that individual would get electrocuted. So it's basically a prevention mechanism to avoid backfeed into the grid. So so that is unless you have batteries, that the system would shut down.
Okay, thank you.
All right, so what are the optimal roof characteristics for solar? So condition and type. It's recommended that you have at least 10 years of remaining roof life at the time at the time of the project to install the solar panels. And this is mainly to mitigate future removal and reinstallation of solar panels in case you have to do a roof replacement. the basic point is solar panels can be mounted on any type of rooftop material. Asphalt shingle is the most common, but you know, basically Spanish tile, concrete, metal, all kinds of different types of roof. It is possible to mount solar panels on them. The key is, though, you have to just make sure that the solar company that you're working with, you have to make sure that they have the experience in installing the solar panels on that kind of material, if it is something that's a little bit more unique. Sunlight and shading, as you would expect, the more direct sunlight the panels receive, the more power the panels will produce. And you want to avoid roof locations that have excessive shadings from a tree, a chimney, or other structures during most times of the day. So very important, very limited or no shading. Roof space, you want to make sure that there's enough space to mount the panels with no obstruction. You want to be clear of vents, skylights, and windows, pipes, satellite dishes, and other items like that. In fact, this picture is a good example. You could see it avoids a pipe over here, a satellite dish, a skylight. And so, this picture here, moving on to this next point, it's about, I would say, it's about a 10 kilowatt system. And the rule of thumb is, in terms of surface area, you can get about 15 watts per square foot. Now that number has been increasing. Maybe 5 years ago, it was only 10 watts per square foot, and maybe 5 years from now, it's going to be 20. But generally, the amount of solar that you can get based upon your square footage available, it's about 15 watts per square foot. So if you're targeting a 10 kilowatt solar energy system, that will require around 667 square feet of unobstructed roof space. And you can see with this array, it's a 3x9, so that's about 27 panels minus the 2 here. So this is about 25 panels, roughly around 370 watts per panel, you could say, for about 10 kilowatts. And then the orientation, this is very important. And I think many folks may know this already, but as far as orientation is concerned, it's basically good, better, and best. Good is east and west facing. Better is southeast and southwest facing, but no question, best is due south, what we would call 180-degree azimuth. And your optimal tilt is basically whatever latitude you are on the planet Earth, that's the optimum tilt of the solar panel. So in Houston, we are at exactly 29.76, so call it 30 degrees. So if your solar panel is due south and tilted around 30 degrees, so that's sort of the optimal orientation. The roof pitch typically is what's going to decide that, right? I mean, the typical roof pitches for residential properties, it's a 412 to 912 roof pitch, which is anywhere from 18 to 37 degrees tilt. So those are some of the key points to think about regarding roof and roof characteristics. Okay, so going through the major equipment here. This is just sort of a look at the solar panel, which is, again, the key equipment and one of the key pieces of equipment in a solar energy system. So you can just see here these figures superimposed on this array. It's a 2x6 array. And so with this example, we've chosen 390 watt panels. So it's 12 panels. So this is a 4,680 watt or 4.68 kilowatt small little system here. And, per the ratio I just gave you all a couple minutes ago, this would require around 267 square feet. The solar panels, they're about 1.5 inches deep. And each panel, you can see it's 6 feet, 8 inches long, 3 feet, 4 inches wide. And then this whole array, at 20 feet by 13 feet, 4 inches. I just chose these panels. I just picked a manufacturer called Mission Solar. They're a U.S. manufacturer based in San Antonio, Texas. They're considered a tier 1 module manufacturer. And this is specifically a 390 watt, 72 cell solar panel. And solar panels typically come in either 72 cell or 60 cell. And the cell represents, if you look really closely at the solar panel, you can see these little squares inside of it. So this is like 6 by 12. And so that basically means there's 72 solar cells inside of it. The material is silicon. That's what most of the solar panels are made of now. And there's basically two types. It's monocrystalline and polycrystalline. So this one from Mission Solar, it's a black monocrystalline solar panel, and it has a a degradation of 0.5% per year. And just like almost all tier 1 solar panels, it has a 25-year performance warranty. So what that means is up to 25 years, they guarantee that each solar panel will generate at least 80% of the production, of the rated production of the panels. Now, some panel manufacturers that are more efficient could go as high as 85 or 90% after 25 years. But again, those will be more expensive. But solar panels, they're from all over the world. There's quite a few made in the US, many in Asia and in Europe. So, it's something where, what you really ought to be looking for mainly are solar panels that are sort of categorized as tier 1 and ones that have what we would call a bankable warranty or a bankable performance warranty with respect to, it's sort of backstop, if you will, financial backstop. So
Raj,
this is the other.
Raj, we had a quick clarification question on the slide just before that one where you're talking about the orientation of the panels. The question was 30 degrees from horizontal or 30 degrees from vertical.
Oh, horizontal. Horizontal. So yeah. Sure.
Thank you.
Okay, so this is about the inverter now. So the inverter is the brains of the solar energy system. It's the, as mentioned earlier, it's the piece of equipment that converts DC power from your panels to AC power needed for your home. And you typically have 3 types of inverters. You have a string inverter, microinverter, and a power optimizer. And the difference between the 3 is that the string inverter basically, essentially all the panels are connected together in series, and they just route directly into this single string inverter, which basically manages the whole array or the whole string. A microinverter actually has a small inverter on each individual panel. So it's different in that as opposed to them all combining together and going to one inverter, there's multiple inverters and they're mounted on each inverter. And then you have a power optimizer, which is kind of a hybrid of the two. It has a string inverter, but it also has something on each panel called an optimizer, which is used to control the panels, control the voltage and current and different, say, conditions of the panel to basically optimize it and generate maximum electricity. Nowadays, most residential solar projects use microinverters and power optimizers. So if you all end up, getting a quote or a proposal from a solar company here over the last few years, probably you're going to be getting an option for either a microinverter or a power optimizer. And the reason for that mainly is because about 3 or 4 years ago, there was a ruling in the National Electric Code that had something to do with the rapid shutdown capability, and these 2 types of inverters are a lot more compatible to meet those kind of code requirements. And also the other advantage of these designs is that it's much better for shading. With the string inverter, if one panel is shaded, then the whole string will kind of go down until everything, the whole array is unshaded. But with these designs, with the microinverter and power inverter, power optimizer, a specific solar panel can be shaded, but just that one panel will be impacted and the rest of them will still be running. So you have a lot more flexibility. And then there's other aspects with respect to long-term cost of ownership, et cetera. Racking. So this is the other piece of equipment. This is kind of on the structural side now. So the racking is the foundation of where the solar panels attach to your roof. And per building code, solar panels are classified as components and cladding. So they must be fully integrated with the building structure. So this means that mounting hardware, it has to be attached to the rafters and engineered to handle hurricane force winds, leak prevention, and corrosive effects of high humidity. And so because of this, when an installer will come to your house for sort of the initial site visit, they're probably going to need to look into your attic to check your rafters to make sure that they're spaced appropriately and they're structurally. These are pictures of some of the kind of major components for racking equipment. You can see here, here's a roof attachment, and this is sort of a waterproof flashing underneath it, to ensure leak prevention. These are rails that are mounted on the roof where the panels will be mounted, aluminum rails typically, lightweight, strong, anti-corrosive. And then these are mounting clamps that are mounted on the rails, and the mounting clamps essentially bite the panels, and that's what kind of holds the panels in place. And then the other major piece of equipment, if you will, it's more software than anything else, it's the monitoring. And the monitoring really, it's super important, because after the system starts up and the system is up and running, this is what you're going to be relying on to easily to be able to see how the system is performing. Obviously, you can go look at the inverter itself and look at the display, but the monitoring is really the main way that you do that. So monitoring is typically included as part of the inverter package, and its main capability is to collect and send real-time power level data and diagnostics through an online portal. So this is a snapshot of the monitoring portal for my own house here in the city of Bellaire. So I installed solar panels on my house way back in 2011. And so this is a view from October 2011 to October 2012. And you can see here, the red curve represents consumption, the green curve represents production. And, roughly from this, you can see that my kind of quote unquote solar offset, which is the ratio of the amount of solar produced versus how much my home is consuming, it's around 40%. And then you can also see that from here. It showed 4.31 megawatt hours generated over the year versus 10.2 consumed. So, roughly around 40%. And, so all of these software packages, these monitoring packages, they have different looks, and there's all kinds of very interesting things you can do with them. And you can, look at them with lots of flexibility, hourly, daily, weekly, over the whole lifetime, even very granular over 15 minutes, you can see the information. So it's really interesting. So now we're going to spend a few minutes here on numbers and analytics and with respect to economics, I would say. This is obviously part of everyone's interested in is how much does it cost? How do I get my money back, payback, and all of that? So, and I'll even say we spend too much time on this compared to other things that we all tend to buy. But when it comes to solar, because it's new to folks, it's really important for folks to understand the economics and understand how it works. So this is just sort of a quick table showing how the numbers lay out. So I'm going to go over it in detail with you and kind of go over the assumptions and the calculations. So let's assume that you have a 4,000 square foot home in the city of Bellaire consuming 25,000 kilowatt hours per year. We mentioned this earlier, Allison, the question that you have. So this would be like a typical home, how much a home would be consuming. So with that home, we're going to assume that you have 800 square feet of unobstructed south-facing roof space with a 30-degree tilt to mount. So that's great. You've got 800 square feet. You've got a nice 30-degree tilt. And per that ratio I gave earlier, we can apply the 15 watt per square foot to kind of come up with the size. And so that's what we do. So here we're able to understand with that 800 square feet, we can get a 12 kilowatt DC system, 12 kilowatt system. And that would effectively be 30 solar panels, 72 cell solar panels at 400 watts each. So that's how that's calculated here. It's 12,000 watts at 12 watts. So you all can understand the math there. And so now, how do we calculate the production? So the NREL, which is the National Renewable Energy Lab, that's a division of the Department of Energy. They have this freely accessible tool called PV Watts. It's a very simple tool to use. And based upon the data that we just went over, the size of the system and the tilt and the azimuth, and data about sunlight sort of radiation in the city of Bellaire, we're able to use that tool and calculate that it'll be around 17,268 kilowatt hours per year. That's what that solar energy system should be able to generate. And based on that, we can then calculate that that represents a 69% offset of the home consumption. That's going to be that 17,268 divided by 25,000, meaning that 31% of the remaining balance will still come from the grid, or it'll come from your retail electric provider. And so now let's make a few more assumptions. So let's say that you are currently paying a rate with your retail electric provider. You're on a 100% renewable energy plan. You're paying a rate of about 10 to 14 cents per kilowatt hour. So that's what you're paying now. So if you take that and you want to calculate what your avoided electrical cost is, electricity cost. So the avoided cost, that's not the 25,000 of what you're consuming now. That's taking sort of that captive solar generation piece, 17,268. And we're basically saying if you didn't have solar, this is what you would be paying annually for that electricity, you know. And again, if it's 10 to 14 cents, it's basically $1,727 to, you know, 2,418. So it's basically going to be in that range. That's what you would be paying for your electricity. And then this is another very big assumption. This is about the system costs. So this is just using rough numbers and all-in system costs. I'm indicating something, you know, within a range of $1.80 per watt to $2.40 per watt. Now, I want to make sure you all know that number is very contingent upon your individual design of your home, the equipment you choose, all kinds of other factors that can impact that quite a bit. So, you know, I picked a range, and, you know, that generally seemed about right for me based upon proposals and stuff like that I've been seeing, at least over the last year, from various solar installation companies. And so with that, you know, you can get a gross cost of $21,600 to $28,800. But what's most important is the net cost, which is after the 26 federal investment tax credit, which many of you probably know about. That is still in effect, and I have some information about that as well later. But basically, the net cost, which you're basically going to multiply times 74%, it ends up being $15,984 to $21,312. So that's what your net cost of the system is. And so with that calculation, you're coming up with just sort of a simple payback break-even point of somewhere between 6 to 12 years. And again, that's very dependent on what your system cost is and what your avoided electricity rate is. And then it's free electricity after that. It's free. I mean, like I said earlier, the solar energy systems, you know, they're designed to last 25 to 35 years or more than that. But once you hit that payback, that's really the way you ought to be looking at it, because it's an investment you made, and, you know, you're basically reaping the benefits of it. Now, definitely, there's in other parts of the country, and even in Texas, paybacks are lower than 6 years. You can, you know, in California, it's quite normal to get 3 to 4 years because they pay higher electricity rates. Many states have rebates and incentives, even in Texas. But, you know, that's probably about where we settle in here in Bellaire. So that is a lot of information. Allison, I don't know if folks have questions. Maybe we'll come back to that.
There are a couple of questions just that I think are appropriate for this slide while we're here. The first
Sure.
is you gave a scenario that included producing less electricity than what you use and showing, you know, you'd get the rest from the grid. But what happens if you produce more than what you use?
Right. And I've got to say that
specifically they're wanting to know what CenterPoint, but CenterPoint doesn't send you the bill, but could it be deducted from your bill is the question that they're asking.
Well, I hate it when presenters do this, but that's my next slide, actually, that question. But is there another question though, or should I?
There is. The system cost that you're calculating there, that total cost, does that include a battery or does it not include a battery?
No, does not include a battery. And I'll touch on battery costs in a bit here as well.
Okay, that's it.
Okay.
Please keep going.
Okay, great. So this was the question about the surplus solar energy sent to the grid. So outside of Texas, this is known as metering. And it's basically the concept of, when solar electricity produces more than what's needed by the home, it sends electricity back to the grid. And so in that scenario, per the question that was just asked, it would be important, depending on the amount of projected overproduction. That's what's important, because if it's going to be a really small amount, then it may not be worth it. But if it's going to be a fair amount, then you would want to get on what are called buyback plans, solar buyback plans, renewable energy buyback plans that are offered by several major retail electric providers. And so that would be what you do to get on that plan and make sure that you're getting credit for that solar electricity that is exported to the grid. And so, so that's really important as well, as making sure that you have the ability to manage that and get that set up correctly. This is a view of the monitoring link, similar to one that I showed you on my house. This is our Evelyn's Park. So, and this is very recent. This was the week before our horrible freeze that we just had. This is a snapshot from February 4th to February 11th. And this is, again, the monitoring system from Evelyn's Park. And you could see, again, the red curve represents the consumption and the green is the production. And I don't know what happened on this day, but you could see there was a big, spurt of overproduction that happened here, where this electricity went back to the grid. This was an example of production being greater than consumption. So that surplus energy was sent back to the grid. So yeah, but the key point is that you have to investigate and compare the various buyback plans that are available. Okay, so how to get a system. So it's pretty straightforward. I say it's not too different from any sort of major service or equipment you may purchase for your home. You kind of go through the process of vetting different solar installation companies, and you find maybe one or two that seem okay and you've got good references from. And then typically there'll be an installer site visit, and then you move into the contract and proposal phase. And then once you get that done, you start the project, design and permitting happens, and then construction, installation and inspection, and then you move to monitoring and maintenance. So this little graph here, though, represents what really kind of is happening on the customer end, basically calling this the solar coaster. And this is one of the things I would describe that many times this is what customers experience when they have solar installed on their home. The y-axis represents excitement. The x-axis, the time horizon, as you move along. So you become aware of solar, and then, you start hitting some peaks and valleys. You're like, okay, you go through the evaluating stage, not great. And then, okay, you sign the contract. You're all excited, ready to go. And then there's a time period that takes some while to get the design and permitting done. And then finally that gets done, and then you're in construction and you got panels on the roof and ready to go. And then you have to wait 60 days, 30 days for an inspection, because that's just the time horizon typically that it takes, with, what we would call the authority having jurisdiction, meaning the group that has to, basically approve and provide the permits and provide the inspections. So that for us would be the city of Bellaire and CenterPoint, which is our transmission and distribution utility here. And the time, I would say, the time horizon for the city of Bellaire is actually not that long. The requirements are not that deep in terms of inspection time, turnaround times, and all that. That's actually pretty good. It's the center point, especially during times of COVID now. There's just a lot that's involved with CenterPoint's ability not only to come out, but they're the ones that are very, very carefully checking the design, structurally, electrically, making sure that everything's accurate and everything's per code. So it takes time, and so there's a little bit of a lull there that's not great, and then finally it gets powered up, and then it's generating electricity, and then there's some time spent on the monitoring, which can be that in itself can take some time, and then everything kind of moves towards a steady state mode where, quite frankly, the best, sort of salespeople for solar installation companies are customers, existing customers, because they tend to be best advocates for solar energy when they tell family and neighbors. So, anyways, so that's sort of a typical sort of a journey that a lot of customers go through. So let's talk about the city of Bellaire itself specifically. Solar in the city of Bellaire. So a lot of this is pretty straightforward. There is there's permitting and inspection requirements, building permit applications, wiring diagrams. There's an electrical permit. And by the way, an electrical permit is also needed for an EV charger and battery storage as well. There's a permit fee. The approval turnaround time typically is about 21 days, but it tends to be sooner than that. It's really important to make sure that the solar installation company is a registered contractor within the city of Bellaire. And then, of course, when the project's complete, an inspector from the city will come out and approve it. And as I explained in the previous slide, all of this is happening in parallel with CenterPoint Energy. And the really big application that's filled out there is what's called the Interconnection Application. That's basically the process that allows your home to connect the solar energy system to the grid. So there's all kinds of protocol that has to be followed for that. And as mentioned, inspections, and they have to essentially sort of green tag the system and give a energization letter before you can go ahead and start it. What's important, though, is all of this should be managed for you by your solar installation company. All the fees and applications, all of that back and forth and interface with the with CenterPoint and with the city. The other thing I wanted to mention is the city of Bellaire just this year signed a contract for solar electricity to be supplied for all its public facilities. There's a new solar farm that started up in Fort Bend County outside of it's called the Fighting Jays Solar Farm. And the city of Bellaire signed an electricity contract where 40% of all of the electricity consumed at our city facilities is going to come from that specific solar farm. So that's a really fantastic accomplishment that the city made happen there. So I want to make sure you all know about that. This is a view of Evelyn's Park Conservancy. So, it's got some, in addition to the interesting sort of environmental designs that have been put in place with respect to stormwater collection and whatnot, a lot of people don't even know there's around 50 kilowatts of solar panels on the existing buildings that are there. The solar panels, they're black on black panels, and they have been designed in such a way with the roof, they are barely noticeable. And so, it's one of these really, it's quite an elegant design, I would say. And it's something that's been in place for a while. And now there's a phase 2 now for the for this solar project. And that's actually happening now. So there's going to be an additional 24 kilowatts that's going to be installed on this little pavilion on end here. So that's coming, later this year. So totally, there's going to be around close to 75 kilowatts of solar that's going to be installed there at the Evelyn's Park Conservancy. Mr. Lou Waters, I'm not sure if he's joined the call or not, but he's the past president and founding board member of the Evelyn's Park Conservancy. And in fact, we were originally hoping to give this presentation as a show and tell at Evelyn's Park, and kind of show everybody the solar panels and whatnot. But obviously, because of the pandemic, we've given the presentation here virtually. Okay, so battery storage. So let's talk about this. This is tremendous amount of interest in this, especially with the freeze that just happened. A lot of folks are considering batteries, of course, gas generators for emergency backup power. Really, I would describe this more as solar batteries as opposed to just pure batteries, because batteries on their own, they provide they do provide an important service, but really when it's combined with solar, that's when you're getting sort of the full capability of the battery. And so, this is a picture of an installation. This is not the city of Bellaire. I'm sure you can tell from this picture. but it basically shows one storage unit. Basically, it's a power wall from Tesla is what would look like. But again, other companies have very similar looking units as well. And so with one unit, it would be sized as a 5 kilowatt, 13.5 kilowatt hour unit. And so with one unit, you can power, I would say, the minimum requirements for your home. And that would be your sort of 120 volt service all around your home. And so, of course, that would be like your lights, your space heater, internet, charging your phones and your laptops, TVs, electrical outlets, all your kind of 120 volt stuff. It would be able to power that. But, sort of your 240 volts and higher sort of load items like these ones in red, it would not be able to, power them. And so to do that, you have to add more batteries, 2 or 3, and then you could see proportionately the size increases. And with that, you can do more with it. You can do more with it in terms of being able to power these different items. And so basically, a solar battery, it's 3 main purposes. It provides continuous off-grid emergency power during a utility outage. So again, when you have solar panels and you have a battery, you can basically just run off-grid because the batteries are, they're basically supplying power to the home, and then they're providing power to the battery. And then when the sun sets, the battery's just sort of discharging at night, kind of keeping you through, and then it recharges during the day. So, effectively, it just works in an off-grid manner. And then also when it's not an outage, there's all kinds of other sort of value creating capabilities that a battery can perform. One of them is, load shifting for surplus solar electricity. So how we talked about how you have to get a buyback plan and whatnot when there's surplus solar electricity. Well, if you have a battery, all of that electricity can just sort of be captured in the battery, and then it can just be discharged at night. So effectively extending your solar day by a few more hours, in the evening. So, that's a capability. And then also, depending on the rate plan that you have, you can sort of get these free nights and weekend rate plans. You could do some different things that'll allow your battery to sort of work within a time of use rate optimization scheme where you can sort of monetize that and figure out ways to save money that way as well. So and so as far as costs, so we talked about costs for solar. Again, this is a rough number. This is just based on my own research, including labor and after a tax credit, which you can get when you install it with solar. It would be around $9,000 for one unit. And then, of course, it would be, for 2 units and 3 units, it would be more. I don't think it would necessarily, though, be, 18,000 for 2 or whatnot, because, there would probably be some savings based upon economies of scale or whatnot. But one of the cool things with Tesla Powerwalls, as well as other battery manufacturers, is if you want to add 2 or 3, you don't have to find, say, like another wall space. You can sandwich them, or you can kind of stack them, right back to back next to each other. So that saves some room, when they're mounted on the floor. So, and then the other thing I wanted to just bring up is as far as HVAC. So obviously this is what everybody thinks about during a power outage is their fridge and their heater and their air conditioner. And, the running load of an HVAC system, that's actually not the problem. Like say for a battery to be able to handle, it's the startup current. That's really where the electricity is needed. What's called the locked rotor current to just kind of get the wheels turning, if you will, in the rotating equipment. And that's where a lot of the electricity is really needed to get going. It's not so much with the running load. Okay, I'm going to just show you here now an interesting video that I thought was kind of neat to share with you all. This is a futuristic car that actually has solar panels on the roof to charge it. So take a look at this video. So very, very futuristic. That's kind of like a sunflower solar panels coming on the roof of a Tesla. I don't imagine we're going to see one of these on the roof of our local HEB, second floor parking lot anytime soon. But anyways, neat things like that are happening with EVs and EV charging. So let me spend a little bit of time talking about EVs now and EV charging. I know many of you own electric vehicles, or many of you are considering it. I just wanted to spend a few minutes kind of going through some of the basics because it can be a little confusing. There's basically 3 charger types: level 1, 2, and 3. And in the vernacular or lingo of EV charging, the miles per hour is how many miles can you charge per hour in terms of charging miles. So if you get a level 1 trickle charger, that's just 120 volt. That is basically very seldom used because it takes a very long time to charge a typical car. It would take 40 hours. So that's really not realistic. It would you would only do that if you don't have time, if you have a lot of time or you have no other option. What's normally used is a level 2 charger. This is a standard charger, 240 volt, kind of like the outlet that you would have for your washer and dryer. And that charges at around 35 miles an hour. And so that typically would be from 6 to 8 hours to charge your vehicle, let's just say an empty vehicle. And that's the most commonly used. It's what's, most folks have at their home or at work. They use to charge during the day. And then there's level 3, which is a totally different type of a charger. These are what's considered the fast superchargers. And these are at 400 miles per hour. So typically you can charge your car in 30 minutes or so with these. And they're very much set up for just targeted use, road trips, or someone maybe that lives in the city and they just may not have a home charger and they just want to be able to go to public, or I should say third-party supercharging stations and just charge their car every few days. So those are the basic charging levels. And these are the plugs that, again, many of you that have electric cars know these plugs, but all Teslas have this plug right here. That's what it looks like. And all non-Teslas have this plug. And this is generally called a J plug or J1172. The top part is what's used for level 1 and 2. And then when you add the bottom part for the CCS plug, that's what you would use for the supercharger. And so, if you have the right adapters, which are very readily available, the key point here is that any Tesla can charge at any charging level 1 or 2 charging station anywhere, and vice versa. Any non-Tesla can charge at any Tesla charging station as long as it's level 1 or 2. But for level 3, it is totally restrictive. It pretty much is only Teslas can use level 3 Tesla fast chargers, and only non-Teslas can use non-Tesla level 3 fast chargers. That's just the way they're set up. And so, what's really important is also to become familiar with these third-party charging station companies, these EV apps. They're all over the USA and Canada, of course, beyond Tesla. These companies, PlugShare, ChargePoint, EVgo, and Blink. So it's all very interesting, the way they've set up their infrastructure, and it's growing quite a bit. And I just wanted to, just talk a little bit about EVs here and just put a plug in for EVs. As again, I know a lot of us have EVs, and many of you may be thinking about it. You're hearing a lot about them. This is a picture of a beautiful sort of reimagined Ford Mustang. They launched it last year, and it's called a Mach-E. And basically electric vehicles now, they're quiet, they're fast, they're safe, they're comfortable. And as far as being safe, many of these electric vehicles, they have, so many cameras all around them, and there's all these sort of safety features built in. They're affordable, they're low. On the affordability, there's a tax credit that's still available of $7,500, except for Tesla, because Tesla met its quota. But the other manufacturers, if you buy an electric vehicle, you can qualify for a $7,500 tax credit. And they're very low maintenance. We have 2 electric vehicles. Pretty much we check the tires, windshield wiper fluid. That's about once a year. That's typically all we have to do because there's no internal combustible engine, right? There's no ICE internal combustion engine, so you just don't have as many of those moving parts and whatnot. They're fun to drive. The range, everyone have range anxiety. When EVs first came out, they used to only have, say, 100 to 150 miles of range. Well, now they're routinely over 250, even up to 350 miles now. There's many EV car choices. You all may have seen announcements from Audi their entire fleet's gonna electric vehicle by 2025. I think Volvo just this week or last week announced that they're gonna go all electric as well. And the quick point I wanted to make here is many of us don't realize that 95% of the time your car is idle. Okay, now some of you may drive quite a bit, so it's gonna be less than 95%, but generally, we only use our cars 5% of the time. So that's sort of the idea is during that time when it's idle, that's where you should, try to figure out a way, an efficient way to charge your car. So I'm going to stop here and yeah, we can jump into question. I have some FAQs as well that we can get into, but yeah, thank you all very much. I know I packed quite a bit during that presentation. I appreciate y'all taking the time to listen and follow everything. So anyways, Allison, turn it over to you. Oh, you're on mute. You're on mute.
So, thank you. Yeah, I would say let's go right into the FAQs because I think they will address some of the questions that we have. We do have a lot of questions that came in through the chat. Most of them are about batteries, but some other ones. But I think if we just go, that would be helpful.
Okay, so let me just kind of go through these. I think I've got maybe a couple of battery ones in here, so I'll just try. I'll just try my best, and then we'll definitely catch them here as much as we can. So what's the status of the solar tax credits? So Congress did it last year, so it's going to be at 26% this year, 26% next year. Then it steps down to 22%, and then it goes to 0. So pretty much, this is what you're looking at in terms of the horizon for being able to capture that all-important tax credit kind of going forward. So that's that. Can I get a loan for my solar energy system? Yes, for sure. The solar installation company will be able to point you to a loan provider. Many of them offer really flexible payment terms, competitive interest rates, innovative solutions timed around your tax credits as well. So that's something as well that you may want to look into. Do solar panels work?
Raj?
Yeah.
Raj, on that question, there were a couple questions about the difference between buying or leasing, because some people are seeing ads for these leasing, 0 down, 0 out-of-pocket costs. They want to know, are those scams, or what should they think about?
Yeah, right. So no, they're not scams, and in fact, one of the largest solar leasing companies in the entire country is right here in Houston. It's called Sunnova. They're right here in Greenway Plaza, and that is their bread and butter model. They do solar leasing. But the concept, it's the largest players. Sunnova is one of them. There's another company named Sunrun. Y'all have probably heard of Vivint, a few other big players out there, and that's what they do. Basically, no upfront cost. You just pay them a fixed payment for the solar panels, and they maintain it, they own it, and it's typically a long-term agreement. Now, there's all kinds of different sort of hybrid models and different types of solutions, that are sort of tied to that. What I was referring to here was more of just a loan. You just look at it as more of like a loan, like for your car and another type of a loan, if you will. But yeah, solar leases also products that are available, and I would say they've kind of gone through a phase now where in Texas, let's say viability for solar in general, including solar leases, it was tough just because the economics were tough to pencil out. But now that costs just keep going down and down. I didn't get into that because there's just too much content. But there's a slide I was going to show you all showing how much prices have dropped over the last 5 years with solar energy systems. And now because of that, these leases and loans and just straight purchases are just better now. A 6-year payback we really couldn't get to in the past. It was more like 8 or 9 or 10 10-year payback, so, okay. So do solar panels work on a cloudy or rainy day? So yes, most definitely solar panels work on a cloudy or rainy day. They generate as much electricity, but and then you do have some days where it's really dark, so dark that our photocell lights go on and are hard. But so if it's those kind of conditions, yeah, it's going to be tough. But if it's sort of a cloudy day, it will still generate electricity, maybe only 50% of what it would do on a sunny day, but it still will. Here's a battery question. Well, actually, this was a question that was asked earlier. Without batteries, will solar still work during utility outage? So yeah, we covered this, but this was essentially what I was saying. It was per NEC code. Yeah, there's sort of an automatic shut-off mechanism so that there's not an unexpected electricity backfed into the grid.
Raj, there was a follow-up question to that about whether if you have a backup gas generator, will your solar still continue to work?
Yeah, that's a very good question. I would say that the answer is yes. I think now with what has been designed for some of the systems now, there is a sort of a capability with solar. Okay, well, I should take that back. Maybe that's solar with batteries and a generator, but I think if it's just a pure generator, if it's a solar only with a generator, then no. Yeah, but if it's solar with storage and a generator, then yes, then the solar can still work. With a generator, it wouldn't work because a generator is just producing electricity. It's not storing any electricity, and so because of that, the solar needs somewhere to go, and it would it wouldn't be able to work within that manner. But again, that is an evolving area. I know there's one company here in town that has advertised working with solar and with generators together. And I think they are advertising some sort of compatibility, but I haven't researched it enough to really fully understand it. What happens to my roof if the solar panels are removed? So the company that performs the removal, they're supposed to restore it as it was before installation. Again, normal wear and tear, just like your roof has normal wear and tear. All the screw holes, they will be properly filled and patched to pre-installation condition with high quality roofing materials. So, again, people do worry about holes being put into their roof. I will say for a few of you who do have a flat roof, which, now have flat roofs, there are ways to mount solar panels without poking holes into the roof. It's called a ballasted system. That's very common for commercial systems. But again, for most pitched roofs, you do have to, basically drill holes in the roof. But again, restoring them is something that's very common, and it's, generally, it has to be done in a way so that it will not, say, void the roof warranty, for example. That it has to be at that level of quality. Will adding solar?
Raj, there were a couple other roof follow-on questions earlier in the presentation. So there was a question, and I think you addressed that most of these solar panels are rated to withstand hurricane force winds. But there was a question about that rating, and then they wanted to know if you have solar panels on your roof, is there a chance that it will diminish the ability of your roof to withstand high winds by having the panels on top, or will it extend the life of the roof that's covered?
Yeah, it's the latter. It actually will extend the life of the roof, just because, well, one of the reasons it's just not absorbing as much heat, right? It's not absorbing as much heat as it normally would. Basically, I think what is it, category 3 winds, it's 125 miles per hour. That's what they're rated for. That's what solar panels are rated for. And so, again, the code requirements, especially here in the Gulf Coast, they have to meet that. So, so in general, it's as far as the roof and, say, the degradation of the roof, there really isn't anything specific from the standpoint of its causing damage to the roof. If there's going to be damage, and I've got a slide here about hail, like for example, let's just say if there's a big hailstorm, and then so people worry about what's going to happen to the panels. Well, the roof will get damaged before the solar will. So, it's when you have things like that, it's basically sort of like a common envelope that sort of works together, and it's not so much sort of independent that the solar panels will impact the roof as much. So, okay, let me keep going here. As far as property value of your home, will solar increase property value of your home? So a recent study by Zillow showed that homeowners who purchase a solar energy system, they increase their property value and they sell their homes quicker. The study showed that homes with solar energy sell 4% higher than homes without solar and solar power. And on an average, that's about $15,000 to $20,000 more. Now, again, there's probably all kinds of data in there, and I'm sure it's a big cross section around the country, and maybe it's maybe referring to more expensive markets where electricity rates are higher, but that's one very good data point that we were able to capture. Are there different looking solar panel choices? This is something.
Raj, quick on the valuation. There was a question about whether or not for appraisals here in the Houston area, whether having solar is included or excluded when they do the valuation of your home, right? If you know the current status of that. Right.
So there's good news on that. Well, first of all, because there's a related part of that question, which is property tax. So in other words, if the valuation of my home goes up because of solar, does that mean that I have to pay more property tax? Well, the good news is a law was passed a few years ago in Texas that makes the solar energy systems exempt from property tax, for improvements to the home from solar energy. But yeah, as far as it becoming included in the valuation of the home, yes, it would be included in the overall value. But as far as let's just say being exempt from property taxes, there is a way to basically make sure that it'll be exempt. The mechanism for that, I think we have to kind of check with your accountant and maybe some other folks like that, but they're supposed to be exempt. I just don't know. I think maybe the quick answer to that question is, does HCAT include solar panels in the valuation or not? And I don't know, but I can get back to whoever asked that question. It's a very good question. I can get back to you all on that. Are there different looking solar panel choices available? This is very important, right? Aesthetics are very important. In fact, most people I know that are really interested in solar won't do it because it's facing the street, and they're afraid that it's going to, impact property value of their home. It's going to make their home one that would not sell. And I would say that's a very valid reason. I mean, I fully understand that. I mean, the solar panels on my home, they're not visible. They're just in a place where they can't be seen from the street. But there are a lot of new solar panels out there. They are expensive, but you all have probably heard of solar shingles. The whole technology called building integrated photovoltaics, translucent clear solar panels, black on black like the ones at Evelyn's Park, frameless panels, bifacial. Bifacial means those are solar panels that capture the sunlight from both sides, not only one side, but also from the bottom. And so there's a lot of neat things you can do there, like if you have it over as a canopy, maybe in your backyard. So there definitely are a lot of choices out there. And again, they're going to cost more, but they definitely are. And then as far as installing a electric vehicle charger at your home, I'd say somewhere between $500 to $1,500 for a level 2 charger. Again, it all depends on what kind of equipment you buy and how far away the sources of the 240 volt, etc. But that's about what you ought to expect to pay. Maybe again, for if you have some better equipment, it's going to maybe be on the higher end there, maybe even high as $2,000. Okay, and then I've just got this one more page here, Allison, and then if there's more, we can. So, will my property tax and insurance increase with solar? So this was the question that was asked earlier that I was referring to, and there was a law that was passed way back in 2013, HB 2500, that exempts property tax increase due to improvement to your home from adding solar energy. Your property insurance should not increase. That's what we've seen when, it's declared with your insurance company, but it is something that should be checked with your insurance company. But what we've seen is that it does not increase your insurance policy. This is what we talked about with hail. Will hail damage solar panels? Yes, they will, but they're also going to damage your roof too. So that's what we've seen is when there are hailstorms, we do projects all over the country, and when we've seen some bad hailstorms, the roof goes out in some cases before the solar panels do, in terms of damage. And then this is a common question for many folks. What if I physically cannot install solar panels on my home? Maybe you're a renter, or you live in an apartment or whatever, or you're just in a very, very wooded lot. Well, the easy answer there is you can get on a 100% renewable electricity plan with these retail electric providers. But those plans are, I would say they're okay. They're based on what are called renewable energy credits. Those are sort of environmental attributes associated with renewable energy in the grid. So it's kind of a macro level sort of benefit that's tied to renewable energy. And it is a real thing. I mean, don't get me wrong, but, similar to what Bellaire did, something that's more along the lines of a community solar model, where there's sort of a direct line of sight from a solar farm to your property. Those are becoming more and more popular. And again, that's what the city of Bellaire did with that Fighting Jays solar farm. And so, and there are a couple plans right here that I found. Green Mountain Energy has something called Solar Spark. MP2, there's a solar farm with one of our friends. He has a solar farm out in Katy, Texas, called it's Local Sun. So that is kind of a more of a direct line of sight to your to your property. And can I use battery storage without solar? Of course you can, but you won't get the 26% tax credit at the moment. Now maybe there's going to be a bill that's going to be passed later this year in Congress that will allow for a standalone battery storage tax credit. But for now, it would have to be in combination with solar. But if you have it by itself, you're only really able to use it during an outage, and you can't really use it off grid because after a few hours, it's just like the battery on your phone, right? I mean, if it's not charged, it's just going to go out after a few hours. And that's what you have if you do battery storage without solar, that it's not going to be replenished, if you will. So those are the FAQs. Oh, you're on mute again, Allison.
Thank you. Yeah, my dog kept trying to bark, and so I was trying to keep that from interfering with you speaking. Okay, so there are a few more battery questions. So that last question, I think, kind of leads into those. Time check, we are at about 7:43. So we'll see how long it takes to go through the battery questions, and then it can determine how many more questions we could address. Yeah. So first, there's a question about, can you add a battery to your solar installation after the fact if you've already installed solar?
Yes, absolutely, you can. So, what you've got with the battery design, you sort of have what is called an AC coupled and DC coupled design. So DC coupled means that the battery and the solar energy system share the inverter. So it's actually one inverter. And that's kind of how the Tesla Powerwall works. For example, if you get Tesla solar panels and Tesla Powerwall, the inverter is one. And so that you kind of have to do at the same time. But if you do it after the fact, then you could do what's called an AC coupled design, which is separate inverters. And it's doable. Some of the capabilities they just have to be sort of programmed in a different way. But absolutely, yes, it's doable.
Now, there were several questions about how big of a battery do you need? How long do they last? Sizing, that sort of thing. Is there a place that you could point the attendees to go for more information, or how they can find out more about what they would need if they want to install a battery?
Yeah, I mean, again, I would say that there's I'll point you to like one of the best websites out there. It's called Energy Sage, SAGE, Energy Sage. And that is your sort of like Wikipedia for solar and storage and everything. It's very, very user-friendly and very, very good, simple language. And they're a great resource, But at the end of the day, it really will come down to sort of understanding what your loads are in your home. You know, you've got to be able to have somebody do an audit, or yourself do an audit of all your equipment, understanding what your loads are. You know, how many refrigerators do you have? You know, what are the wattages of your washer and dryer, and your range, and your pool equipment, and whatever. And somebody has to kind of do sort of a load analysis of your property. And then from there, then you have to understand, okay, do I want it all? I mean, do I want my entire home powered up? And if your goal, quite frankly, is just an outage and you want your entire home powered up, I would say gas generator is probably a better choice for that purpose. Because if all you care about are those 2 or 3 days, as of right now, because of pricing and because of you know, the relationship with solar, I would say if that's what your goal is, then yeah, I'd say logically that's probably the better way to go. But what you're missing is that if you don't go with, say, a solar battery, is outside of those 3 days, you have 362 days in the year where the battery is doing all kinds of other stuff for you. You know, it's creating all kinds of value for you. You know, yeah, just, you know, like I explained earlier with respect to load shifting and other functions. So yeah, so that's really what you would have to do. Like I pulled up the slide here because this is the wattage, right, that we're talking about here. 5 kilowatts, that's 5,000 watts, 10,000 watts, 15,000 watts. So a quick back of the napkin, just add up all the wattage of all the loads in your house, see what that number is. And what this is telling you right here is that, you know, if you've got 15,000 watts or 15 kilowatts of load in your home, then, you know, that will last for about 2.5 hours with this battery just going, you know, as it is. And then it'll basically discharge and die out unless there's something like solar that will recharge it. Then, of course, that's how you size a generator as well. You know, it's based upon wattage.
Okay, a couple of mechanics questions about batteries. I've got someone who wants to know, can the batteries continue to be charged while you're drawing power off of them? First question.
Yeah, you know, that's a very interesting question. You know, there's something they call round trip efficiency with respect to how the batteries are, you know, the charging and the discharging. What I will say, again, not being an expert for sure in storage, I think the quick answer is no. It's basically one or the other. It's either charging or discharging. You know, in basic terms. Just, you know, and again, just in the most rudimentary way, I would say that. So.
Okay. And then we have someone who wants to know if the battery can charge off of the inverter, or does it go direct from the cells?
The battery? Yeah, so the battery always goes through the inverter, right? So, you know, it's basically it's a design that there's like, well, even looking at this little picture, there's an inverter built into this power wall. And the inverter, like I said, that's kind of the brains of how all of the electricity, it's the controller of all the electricity that flows around everywhere. So yeah, so no, so everything would be flowing through the inverter. And again, if it's a DC coupled, if it's an AC coupled, it would be 2 separate inverters, like I mentioned. So.
Okay, and then I did have someone ask, if you purchase a power wall, a type of battery, and you install it, can you uninstall it and take it with you if you move? What they want to know.
Oh yeah, of course. Oh yeah, you can even take the solar panels if you want and move. You know, yes, of course. Yes, you can. I mean, yeah, and that is a good point, because that's one of the things with Tesla power walls. I don't have one, but you know, and maybe not Tesla, but you know, I'm looking at storage myself here, possibly in the next year. But you know, they first of all, one power wall can mount on the wall, but if you get 2 or 3 stacked together, they would be on the floor. But they are very much, you know, transportable and movable, of course. But of course, you have to have all the associated wiring, and you have to probably rewire it wherever you have to go. But yeah, yes, you can do that.
Okay, a few people have asked if the city of Bellaire publishes a list of approved solar contractors, or where they should go to find approved solar contractors.
Right. Very good question. So the city of Bellaire does not publish a list. The city of Bellaire, what they do, they just want to make sure that anybody that does business in Bellaire is registered with the city. They've got the minimum requirements with respect to, insurance and other sort of basic requirements. So there really isn't any qualification step there. But, that is a list you can look at least. And I think that possibly could be available. I'm not sure. But as far as finding who solar installation companies are in the area, there's a lot of them. And, I would just say, to be honest with you, I would start off with your trusted friend or family member that maybe did solar in the area, and just start with them and talk about their experience and find out who they used. And then, beyond that, Google searches, again, that website I said, Energy Sage, you can put in your zip code and all these companies will come up. There's definitely lots and lots of resources out there, and there's many, many good companies. One of the things I would want to mention, though, and I should have put this in my slides, is that there's a certification called Nab Sep Certification, N-A-B as in boy, C-E-P. And that is a certification that you want to look for with a solar company, a company that has a few people on their staff, the engineers that have that certification. That's sort of like a minimum level of competency, if you will, for a lot of solar companies to have a Nab Sep certification. So that's something that you want to look for. So, like, I bet you if you Google Nab Sep certified solar installation company 77401, you're gonna get all kinds of hits right there.
Okay, and then there were a couple questions about the buyback plans. One person asked if they've already signed it to your contract with their current retail electric provider, are they still going to be eligible to do a buyback plan? That's the first question. Yeah, so it can be kind of tricky business with these REPs and the way they do it. The first thing you want to do is you want to understand if your existing REP has a buyback plan. So, like, for example, if you're with TXU and you just have a regular electricity plan with them, TXU has a buyback plan. So, you would talk to them about, switching to one of their buyback plans. You would typically do it. You can just wait until your contract runs out. It's probably okay if it's the same company if you change plans within, say, like if you have a year contract. Some of them may have sort of a breakup fee or a penalty to do that. I believe if you go to a different company, there will be one. What my recommendation to a lot of my friends who've gotten solar, though, is don't necessarily just jump immediately to a buyback plan when the solar is installed. Just give it a few months, see how it's going. You're not going to lose a ton of money, over 3 or 4 months if there's electricity going back to the grid and you're not getting credited with it. But study the how it is first, understand what the volume is, and then probably it's going to be okay to just wait until your plan expires, then to shift. But there's many companies. Green Mountain Energy, of course, MP2. Chariot Energy, great company. They're really big with solar, and they've got really great renewable energy plans. Again, I have to be careful naming companies because I'm sure I'm missing and forgetting a whole bunch of them. But it is something that you want to look at because what I'll just say there is some of them will give you sort of a buyback plan in which they will charge you for the normal electricity at a rate, and then the buyback is the same rate, but it's at a higher rate. Some of them will give you the regular electricity, the low rate, but then the buyback is a super low rate, like it's wholesale. So, so you just have to kind of crunch the numbers a little bit to understand, what's the best. So. Okay, and then we're at about 7:54. How many more questions do you want to take? we started to lose some attendees, but we're still about half as many attendees as we had at our peak.
Okay, great. Yeah. Okay, go ahead.
Okay, so let me ask you a question. We had a couple of people ask about the efficiency of the panels and whether costs are coming down, and then according to that, since you shared with everyone that you put panels on your home 10 years ago, they want to know, are you now receiving free power, and when was your break-even period if you are? Right.
Well, I'll ask the last one. So I bought them when they were real expensive. I'm a solar guy, so I mean, how could I be a solar guy and not have panels on my own home? So I paid a lot of money for them. My break-even payback I think I just hit it, okay, going on 11 years. You know, back then, I think I paid $3 a watt or maybe even more for the system. But it's okay, it's fine, you know, because again, just obviously all the learning and all of the, you know, just the ability to use it and experiment with it. So, so for sure, prices have dropped a lot especially panels individually, you know. Just only about a couple of years ago, it was about 30 or 40 cents per watt per panel. And now they're in the 30 cent per watt. And that is a tariff that's a tariff that's on top of that. If the tariff was removed for imported solar panels, the prices would be even lower. So all of the growth in solar has been in spite of this tariff that's been in place. But in general, yeah, I mean, that was my experience. It's been working fine. I think I had one issue with the inverter one time where I did have to have the company come out where there was some part that was that had to be replaced with the inverter, and so that was probably the only kind of issue that I faced. I've only cleaned them once because it rains so much here in Houston. You don't really have to worry about dust collection because there's so much rain on them. You do have to worry though a little bit about nests, you know, possibly rodents and things like that. That's one of the important reasons why you do want to maybe have it maintained, you know, if not every year, every few years, just to make sure that there isn't something, squirrels, things like that. Sometimes squirrels like to chew up cables and things like that, you know. So, and what was the first question, Allison? I'm sorry. There was two questions there.
Well, you kind of went there because the question was whether costs are continuing to decline or if they've sort of plateaued and if efficiency has continued to improve.
Yeah, efficiency. I mean, the best example was, remember I told you that it's 15 watts per square foot. Well, that used to be 10 watts per square foot. I mean, and so just the same size solar panel, you're just getting a lot more electricity, a lot more energy out of them. Still compared to other technology, the efficiency of solar panels is still not really high. It's not like really high, say, compared to wind and some of the other big technologies, you know, where from an efficiency standpoint, somewhere between 15 and 20%. But as far as, you know, the trajectory, it's been really tremendous over the last few years. So, and the main reasons it's happened is because of scale and deployment.
And there is a question about whether you can install solar just for a specific piece of equipment outside your home. Like, can you have solar just for your pool equipment, for example?
Yeah, you can, you know, but that pool equipment then would have to be sort of disconnected from the from the grid. Now, if you want it to be connected to the grid and to the solar and only solar to be dedicated to it, then you'd have to set up a kind of a transfer switch scheme. Either automatic or manual. So that is possible. And I know folks have asked about stuff like that. And some of that is even with the technology I mentioned earlier about solar thermal. You know, there's solar hot water heaters and for pool heaters, and that's another technology. I don't know much about that, but I understand those are very efficient as well. But to answer the question, I do believe with a sort of automatic transfer switch scheme, you can do that.
Okay, let's see. We are 2 minutes to 8, so I'm going to try to throw you one more question.
All
We
right.
had some infrastructure questions with people just sort of wondering, you know, does this have an impact on the grid? So one question was, you know, if everyone's charging their electric vehicles at night and they don't have batteries, right? Is it going to draw too much on the grid and damage the infrastructure, right? Is there a concern that, you know, that's a problem? That was a question, and whether or not these, you know, would be somehow destabilizing throughout the grid. Like, does having the solar come onto the grid destabilize things?
Yeah, I mean, at a high level, this is the difference between what you would call centralized power generation and distributed power generation. And this is what's called distributed generation. It's the whole concept of having the source of production being at the point of consumption. And so that's what you have, like when you have solar. And of course, battery that's you know, in that specific question, drawing from the grid. But generally, distributed generation in general, it is disruptive. There's no question about it. It is just totally disrupting, because now, you know, the easiest way to say it is there's a lot of money been spent on these poles and wires. And if there's just not as much demand now to use those poles and wires, because all of it is now being sort of contained at the local level, then, you know, you have potential stranded costs and things like that involved. In fact, in California, they have so much solar. They have something that you all can Google, is something called the duck curve. Look that up. It's very interesting, because they actually have a problem with, they have just too much solar coming during the day on the grid. And so when the sun sets between the hours of, say, 6 and 9, they've got a big, huge spike in demand from the grid. And it looks like a duck when you look at the graph. They call it the duck curve. But yeah, so there definitely is sort of impact that's having, but it's opening up tremendous opportunities in other areas, technologies with respect to demand response and other kind of optimization areas where we can, you know, reduce our reliability to the grid and optimize and kind of work more towards a, call it a microgrid type structure, where you have the ability to just sort of generate your own power completely within your home. And, you know, maybe we may be in a situation where you can be the other way around, where your electric car, you can sell your electricity to the grid at night and or at other times of the day and make money off it, you know. And there's things like that that are coming in the future. And different markets in the US are experimenting with things like that. So there's definitely a lot of disruption. And Texas is, you know, Texas is probably going to be seeing a lot of that as well. So.
Wonderful. Well, Raj, there were a few questions in the chat that probably were going to require a lot longer, you know, in terms of trying to address. You had given your contact information earlier. Do you want to share that again real quick for those that have questions?
Yeah, just here's my email address. This, it's rpandia@bellairetexas.gov. You can just use that. And yeah, just reach out. I can't see any of the chat or any of the questions right now, that just the way my configuration is. So I'll be interested to see that, Allison, here after we drop out, kind of just understand all that. But yeah. No, but
I can share a couple of the questions with you, but unfortunately I don't have a view to like full contact information for the attendees either. So please, attendees, if you have questions that you want to go into detail, Raj, please reach out to him, you know, send him an email, because like I said, just with the nature of this, we even have some anonymous users. It doesn't give us email addresses or phone numbers or anything. Thank you everyone for attending. Raj, that was fantastic. The really positive comments in the chat. Everyone felt like this was very educational, and we got many thank you for running the session. So kudos to you. This is seems like it was very informative.
Yeah, absolutely. And we're going to be doing these once a quarter on different topics. So we're going to have one in the next quarter, probably going to be focusing on recycling. And then we're going to have other topics every quarter, the Environmental Sustainability Board. So, so this was our first one, but really appreciate everyone joining. And thank you so much, Allison, for coordinating and moderating and facilitating. So.
All right. Bye, everyone.
All right. Thanks, everyone. Have a good night.